Okay, so today we'll be solving question number 9 from exercise 2.1 of the book Challenges and Thrills of Pre-College Mathematics. I skipped question number 8 because it's essentially the same as question number 3. So we need to show that 2 to the power n is greater than n cube by induction for n greater than 9. So we take the base case as n equal to 10. Right, so we have 2 to the power n is 2 to the power 10 must be greater than 10 cube, so 1024 must be greater than 1000, which is true, right? So now for the inductive hypothesis, we say that 2 to the power n is greater than n cube for all n less than equal to k. So 2 to the power k is greater than k cube, right? So what we need to prove is 2 to the power k plus 1 is greater than k plus 1 cube. So this is to prove, right? So we have 2 to the power k plus 2 to the power k is greater than k cube plus 3k square is 3k plus 1. So essentially we already know that 2 to the power k is greater than k cube. So if we prove that 2 to the power k is greater than 3k square plus 3k plus 1 for all k greater than 9, then essentially we are done, because say that this statement is true, then we have 2 to the power k plus 2 to the power k is greater than essentially this equation again, right? K cube plus 3k square plus 3k plus 1, which implies 2k plus 1 is greater than k plus 1 whole cube, right? So if this statement is true, then our inductive step is complete, and we can say that the equation is valid for all n. So all we need to prove in this question now is that 2 to the power k is greater than 3k square plus 3k plus 1 for all k greater than 9, right? Now again, let's take base case k equal to 10, right? So we have 1024 must be greater than 3 into 100 plus 3 into 10 plus 1, which is equal to 331. So this satisfies it, right? Then we take the inductive hypothesis, say 2 to the power k is greater than 3k square plus 3k plus 1 for all k less than equal to m, right? So we have 2 to the power m greater than 3m square plus 3m plus 1. What we need to prove is that 2m plus 1 is greater than 3m plus 1 square plus 3m plus 1 plus 1, right? What do we already have? We have that, okay, let's expand this. So 2m plus 2m greater than 3m square plus 6m plus 3 plus 3m plus 3 plus 1, right? We already have that 2 to the power m is greater than 3m square plus 2 to the power n is greater than 3m square plus 3m plus 1. So essentially if we prove that 2 to the power m is greater than 6m plus 6 for all m greater than 9, then we can say that we can add the rest of the assumption basically based off of our inductive hypotheses. We can add this part of the equation to get 2 to the power m plus 1. We can add 2 to the power m on the left hand side and 3m square 3m plus 1 on the right hand side to get 2 to the power m plus 1 is greater than 3m plus 1 square plus 3m plus 1 plus 1, which is essentially our inductive step. So if we can prove this for all m greater than or equal to 9, then we can prove that 2 to the power k is greater than 3k square plus 3k plus 1 because for all k greater than 9, because our inductive step is complete, and by principle of mathematical induction we can say that the statement is true. So essentially we need to prove, our new question has become that we need to prove 2 to the power m is greater than 6m plus 6 for all m greater than 9, right? Again we take base case, m equal to 10, 1024 is greater than 66, which is true. Then for the inductive hypothesis, say 2 to the power m greater than 6m plus 6 for all m less than or equal to j, right? So 2 to the power j is greater than 6j plus 6. What we need to prove in the inductive step is that 2 to the power j plus 1 must be greater than 6 into j plus 1 plus 6. So we need to prove that 2 to the power j plus 2 to the power j is greater than, so 2 to the power j, oh my god, plus 2 to the power j is greater than 6j plus 6 plus 6. So we already know from the inductive hypothesis that 2 to the power j is greater than 6j plus 6. So if we can prove that 2 to the power j is greater than 6, then we can add 2 to the power j to the left hand side, 6j plus 6 to the right hand side to get the required inductive step, right? So also this is for j greater than 9. We already know that 2 to the power 9 is equal to 512, which is greater than 6, and also we know that 2 to the power n is greater than 0, which implies 2 to the power n plus 1 is greater than 2n. So essentially, since 2 to the power n plus 1 is greater than 2n, we can say that since 2 to the power 9 is greater than 6, this implies that 2 to the power j is greater than 2 to the power 9 for all j greater than 9, which further implies that 2 to the power j is greater than 2 to the power 9 greater than 6, which is greater than 6 for all j greater than 9. So we proved that 2 to the power j is greater than 6 for all j greater than 9. Since we proved this, we can add 2 to the power our inductive hypothesis that 2 to the power j is greater than 6j plus 6. So we get 2 to the power j plus 2 to the power j is greater than this 6 over here, and then the 6j plus 6 from our inductive hypothesis. So 2 to the power j plus 1 is greater than 6 into j plus 1 plus 6. So this is our inductive step. We have proved it. Hence, by principle of mathematical induction, 2 to the power m is greater than 6m plus 6. We proved this by principle of mathematical induction. Since we proved this, which essentially we needed to prove here, we to prove that 2 to the power to prove that 2 to the power k is greater than 3k square plus 3k plus 1. So this essentially proves that 2 to the power k is greater than 3k square plus 3k plus 1 for all k greater than 9. And this in turn was required to prove that 2 to the power n is greater than n cube for all n. I mean, sorry. To prove that 2 to the power n is greater than n cube for all n, basically this part of the question. So we've proved by mathematical induction that 2 to the power n is greater than n cube.